Hello everyone and welcome to my channel Easy Maths. Today the topic which I've chosen to teach you is quadratic equations. Now let me tell you in the beginning, those who are new to my channel, do subscribe to my channel by pressing the subscribe option and do press the bell icon so that you can get further notifications of my videos. Now since we learned quadratic equations, there will be two things which I'll be telling you in this entire tutorial. The first thing is what are quadratic equations, and the second which I'm going to teach you is how to solve quadratic equations. I'll be teaching you certain processes of solving quadratic equations. So without wasting any time, all of you just have a look at this slide which I'm showing you. You see, in the beginning I've told about the definition of a quadratic equation. Now it is written, a quadratic equation in X is an equation having the form ax squared plus bx plus c equals to 0, where a, b, c are real numbers and a not equals to 0. Now if you just look at this equation which I have written here, that is ax squared plus bx plus c equals to 0. All of you must look at this equation now. So here we find three real numbers a, b and c. These numbers are actually having some numeric values, okay, and x is the unknown variable over here. Now as we can see, I have given certain examples so that it becomes clear to you. Example 1, I have given 3x squared plus 6x plus 2 equals to 0. So if we compare this to the definition of a quadratic equation, we find that a equals to 3, b equals to 6 and c equals to 2. I hope you can pretty well understand that, because the standard form is ax squared plus bx plus c equals to 0, and here it is 3x squared plus 6x plus 2 equals to 0. So naturally in this equation a equals to 3, b equals to 6 and c equals to 2. Now let's look at the second example. This is example 2, which is 7x squared minus 13x plus 8 equals to 0. Again, if we compare this to the standard form, we find a equals to 7, b equals to minus 13 and c equals to 8. So we have to be always careful about the sign. In this case we find b equals to minus 13. Now let's move on to the next slide. Here I've given example 3, which is 5y square plus 8y minus 2 equals to 0. This is also a quadratic equation, but this is a quadratic equation in y. In the definition I told you about a quadratic equation in x, but this is a quadratic equation in y. So there's no harm. A quadratic equation can be based on any variable, like it's x or y or z or a, b, c, whatever it is. So here also, if we compare this to the standard form, we find a equals to 5, b equals to 8 and c equals to minus 2. Now let's come to example 4. In example 4 we have 7x squared plus 5 equals to 0. This is a quadratic equation in x. Here we find a equals to 7, b equals to 0 and c equals to 5. Now if you have problem in understanding that, if you just look at the standard form, which is ax squared plus bx plus c equals to 0, and if you just look at this example 4, you will see that there is no x term in it. Okay, we have x squared term and plus 5. So in x square we have 7x squared, so a equals to 7. We do not have any x term, so b equals to 0, and we have plus 5, that's why c equals to 5. I hope that's pretty clear to you. Now let's move on to example 5. Here it is written 6x squared equals to 0. So as you can see here, a equals to 6, b equals to 0, c equals to 0. Because we don't have x term, we also don't have any constant term over here. So it is 6x squared equals to 0. That implies that in this equation a equals to 6. And one thing has to be followed in all of these 5 examples which I have shown. A was never equals to 0, which also satisfies the definition of a quadratic equation. In the beginning only I told you all that in a quadratic equation ax squared plus bx plus c equals to 0, a will not be equals to 0, because if a becomes 0, then a into x square will become 0 into x square, so the x square term will vanish. So we will be left only with bx plus c equals to 0, which will not be a quadratic equation. So the strict rule is a, b, c can be any real numbers, but a will not be equals to 0. Now we come to that part of the video where I'll be showing you how to solve a quadratic equation. Now here I've written solving by factorization method. I'm coming to this after some time, but before that let me tell you, to solve a quadratic equation is to find the roots of it, or in other words, we will find those values of x which will satisfy the equation. Let us think it in this way. Say now I'll show you a simpler example which is not a quadratic equation. Say x minus 2 equals to 0. Now which number minus 2 gives you 0? That is 2. 2 minus 2 gives us 0. So x equals to 2, that is a solution of this equation. Now in this case we find x is equal to 2, which is a solution of this equation. But remember, in case of a quadratic equation there will always be two solutions. This has to be remembered right from the beginning. A quadratic equation always has two solutions. That is, in the answer you will get two values of x. Those values may be same, may not be same. Okay, so now we are going to learn the first method of how to find those values or the roots of the quadratic equation, solving by factorization method. Now I have got some examples over here. The first one we will be solving using factorization. So I take the first example, number 1. We have to solve x squared plus 12x plus 35 equals to 0. Now let me tell you in the beginning, you need to have some idea about factorizing polynomials, then only this method will be very easy to you. Now we will go for middle term factorization. You know, there's a specific method, middle term factorization. To do that, even if you have no idea, I'll just tell you in short. We have to find first a number by multiplying this term c with this term a. We are again comparing this with the standard form, that is ax square plus bx plus c equals to 0. So a equals to 1, b equals to 12 and c equals to 35. So a and c we have to multiply. So multiplying a and c we get 35. Okay, this is the first thing which we have to do. First we have to multiply a with c, and then we have to factorize this number. Now this is something which you must have learned in earlier classes. Say 5 times 7, we can do it in this way. Since 7 is a prime number, so we can stop the process over here. So 5 into 7 is 35. Now we have to break this middle term, that is 12x, in such a way that we get terms from here, and using those terms either by adding or subtracting, we get this term 12x. If it is difficult for you to understand if I say in that way, let's look at this example. So we give the implies that sign because we are solving an equation. So we write x square as it is. Now this 12x term we have to break. See, we have got 5 and 7, so this is a pretty easy example. So we can write 5x plus 7x. Now 5x plus 7x is equal to 12x. So 5x plus 7x is 12x, and 5 into 7 is 35, which we have got again by multiplying 35 with 1. That is 35 into 1 is 35, 5 into 7 is also 35. So first we have to factorize this number 35, which we multiplied by which we obtained by multiplying c and a. So now we have easily broken this, and the remaining term remains the same. Now we go for taking some common factor between the first two terms. X can be taken as a common factor, so we are left with x plus 5 within the parenthesis. Then from these two terms we can take 7 as a common factor, so x plus 5 again equals to 0. Now we have got x plus 5 as a common factor, so we can write x plus 5 multiplied by x plus 7, the whole thing equals to 0. So now actually our problem is solved. Here we have to write in this way: the sum of two expression, I'm very sorry, the product of two expressions is 0. So either x plus 5 equals to 0, that implies x equals to minus 5, or x plus 7 equals to 0, that implies x equals to minus 7. So as I told you, a quadratic equation always has two solutions. So we have got x equals to minus 5 or x equals to minus 7. Therefore we can write x equals to minus 5 or minus 7. One thing has to be remembered over here. I've seen many students making this mistake, writing x equals to minus 5 and minus 7. Okay, the difference between and or must be clear to you. Here we must use the word or, because x cannot be both minus 5 and minus 7 together. A person cannot be one person and another person together, so it's like that. So it will be x equals to minus 5 or minus 7. That is, if we put the value of x as minus 5 in this expression, we will get the expression to be equal to 0. Or even if we put x equals to minus 7 in this expression, so we will get the value of the expression as 0. So we have found the roots of this quadratic equation. Now let's move on to the second example. Here we are with the second example, that is 4x squared minus 9x equals 100. Now looking at this, ax square plus bx equals to something, but we have to bring it to the standard form. So first we will write, implies that 4x squared minus 9x minus 100 equals to 0. So we are just subtracting 100 from both the sides. So we are getting this 4x square minus 9x minus 100 equals to 0. Now this has come to the standard form. We see a equals to 4, b equals to minus 9, and c equals to minus 100. Now again the same thing we have to do. We have to multiply 4 and 100, a and c, though the value of c is minus 100, but we will just ignore the sign in this to make it simpler. 4 into 100 is 400. So we have to break 400 in such a way that we find two factors of 400, either by adding or subtracting we get 9. So let's do it. It's always better to do with prime numbers. So it is 2 into 200, again 2 into 100, 2 into 50, 2 into 25, 5 into 5. We can stop here because a prime number has been reached. Now we have to bring minus 9. So whether it's plus 9 or minus 9, that is not the issue. We have to find two factors of 400. By subtracting or by adding we will get minus 9. So we see 2 into 2 into 2 into 2, that is 16, and here we are 5 into 5, that is 25. If we subtract 16 from 25 we get plus 9. So if we do the opposite, that is if we subtract 25 from 16 we get minus 9 according to the rules of the integers. So we will just do 4x squared plus 16x minus 25x minus 100 equals to 0. Okay, so we are breaking up minus 9x as 16x minus 25x. Also 16 into 25 is 4 into 100, that is 400. Now it becomes very easy. We just take 4x as a common factor, that is x plus 4, and from these two terms we take minus 25 as a common factor, so it's again x plus 4. You must be pretty good with algebra, distributive law, addition, subtraction, multiplication, division of algebraic expressions, so that you can do this kind of simplifications in a very easy and efficient manner. So we are left with a common factor, that is x plus 4, and we are also getting 4x minus 25 over here, that equals to 0. Okay, so we write again either x plus 4 equals to 0 or 4x minus 25 equals to 0. That is either x equals to minus 4 or x equals to 25 by 4, that is 6 and 1 by 4. Okay, so either x equals to minus 4 or x equals to 6 and 1 by 4. So these two are the roots of this equation. Now let's move on to the next example. We now come to the third example, which is x squared plus 5x plus 6 equals to 0. Now I have specifically chosen this example to show you something. Everybody must be careful about this. This is a very good example to show what I'm going to show. Now let's see. If we compare this with ax square plus bx plus c equals to 0, we again get a equals to 1, b equals to 5 and c equals to 6. So we multiply c with a, that is 6 into 1, that is 6. So we have to break 6 into two parts. So this could be 2 into 3. Okay. Now we see that x squared plus 2x plus 3x, that makes it 5x, plus 6 equals to 0. Okay, so we can take x as a common factor from the first two terms, that is x into x plus 2 plus 3 into x plus 2 equals 0. Implies that x plus 2 is taken as a common factor. We are left with x plus 2 and x plus 3, that equals 0. Either x plus 2 equals to 0, which implies x equals minus 2, or x plus 3 equals 0, which implies x equals minus 3. So we can easily find the solution. We have already found the solution. Now I just want to show you something. This is the correct way to do this sum. So there might be a mistake, okay, a tendency of doing a mistake might be there. So that I want to show you. That is why I have chosen this specific example. Now there could be this mistake of not multiplying 6 with 1 and factorizing. Instead of doing that, you could do in this way. Now see, 6 into 1, so 5x could be written as 6x minus 1x, that is x, plus 6 equals to 0. So what if we go in this way? See, 6 into 1 is 6 and 6 minus 1 is also 5. So we could write in this way. But this is a wrong way. Now here comes, how will you understand whether this step is correct or not? Everybody must keep in mind, after breaking the middle term, either all the terms should have a plus sign or all the terms should have a minus sign, or two terms will have a plus sign and two terms will have a minus sign. If it satisfies any of these conditions, then you are proceeding in a correct way. Here we see there are three plus signs. X square has got a plus sign, 6x has got a plus sign, and 6 also has got a plus sign. So there are three plus signs and one minus sign. So this is a mistake. Either all should be plus or all should be negative, all should be minus, or there should be two plus signs, two minus signs, doesn't matter in which order they are. If either of these cases arise, that means you are proceeding correctly with the signs. So if we break 6x minus x, we cannot factorize this. So if we cannot factorize this equation cannot be solved by using the factorization method. See, I just showed you a few minutes ago, the correct way to do that, that was after this step I wrote x squared plus 3x plus 2x plus 6 equals to 0, or I think maybe I wrote x square plus 2x plus 3x plus 6 equals to 0, whatever. You see all the terms are plus, so there are 4 plus signs. So this is a correct way of approaching. This is not a correct way of approaching. You will not get the answer like this. So this point must be kept in mind. With that, we come to the end of this method, that is solving a quadratic equation by factorization method. Now we will move on to the next method. We come to the next method, which is solving by completing the square. Now if you just look at the name, you might not understand anything. I'll just show you how to do this kind of sums, that is how to solve by using this method. I've taken this example. This is example 4, because we have already had 3 examples before. So this is x squared minus 4x plus 1 equals to 0. Now previously we have learnt about two algebraic identities, a plus b whole square equals a square plus 2ab plus b square, and a minus b whole square equals a square minus 2ab plus b square. Now we will be using either of this mainly to solve this kind of quadratic equations, or rather should I say we will be using these identities to follow, which is to be followed in this method. Now see what is to be done. It is said completing the square. Now first of all we have to see that the first term is a square. That is, we have to ensure that the first term is a square. So here we see x squared, which is already a square. So if it is not a square, then what we have to do, that I'll show you in another example. So here we find already a square, so we write it as a whole square, that is x whole square minus 2 into x. Now why are we thinking like this? A square minus 2 into a into b plus b square gives us a minus b whole square. So a square minus 2 into a into b, if we think this as b, so that satisfies the minus 2ab term. So a square minus 2 into a into b plus, then we must have a b square so that a minus b whole square can be formed, that is 2 whole square. So we brought a b square, a square minus 2 into a into b plus b square. Now this plus 2 square was not there in this expression, so we write it as minus 2 square, and the plus 1 is still remaining, so we write plus 1 equals to 0. If you still find it confusing, let me tell you, just have a look at this step first, then at this step. You see x whole square, that is x square, minus 2 into x into 2, that is minus 4x, plus 1 is plus 1. So these two terms we have introduced, plus 2 square minus 2 square. Why plus 2 square minus 2 square? Plus 2 square means plus 4 and minus 2 square means minus 4. So plus 4 minus 4 will be equal to 0. So finally the whole thing remains the same. We have just brought a 0 term in the original term. But why did we do so? So that we can get from these first 3 terms the a minus b whole square form, that is x square minus 2 into x into 2 plus 2 square, that is x minus 2 whole squared. So we have got a whole square over here, minus 4 plus 1 equals to 0. Okay, implies that x minus 2 whole squared minus 3 equals to 0. Minus 4 plus 1 gives us minus 3. Implies that x minus 2 whole squared equals to plus 3. Implies that x minus 2, now when we have x minus 2 whole squared as plus 3, we will have x minus 2 equals to plus minus square root 3. Whenever we are finding the square root, we have to use the plus minus sign, because it could be either plus root 3 or minus root 3. Implies that x equals to plus minus square root 3 plus 2, that is either x equals to square root 3 plus 2 or x equals to minus square root 3 plus 2. We see that again we have got two values of x. So whenever we are finding the square root over here, you must remember that we must use the plus minus sign, both the plus and the minus. Now we move on to the next example. We have the next example here, that is 2x squared plus 5x minus 3 equals to 0. Now, as I told you, you have to ensure that the first term is a perfect square. But here we see the first term is not a perfect square. So what we have to do is we have to make it a perfect square. So to make it a perfect square, the simplest way to do it is to multiply the whole equation by 2. Now, while I multiply 2 into 2x squared, that makes it 4x squared, plus 2 into 5x, that is 10x, minus 3 into 2, that is minus 6, equals to 0. Now this sum, I'll just, to make it simpler, I'll just do it in this way. 4x squared plus 10x equals to 6. I just added 6 on both sides, or you can say I just brought this minus 6 to this side. That makes it plus 6. Now we are left with 4x squared plus 10x on one side. So we have to turn this to a perfect square. That is, here plus 10x is there, so it will be of the form a plus b whole square. So we see 4x squared, that is 2x whole square. Now we have got a perfect square over here, plus 2 into 2x into, see, 2 into 2x, that is 4x, but we have 10x here. So we have to write 5 by 2. Why did I write 5 by 2? Because 2 into 2x into 5 by 2 gives you 10x. If you do the calculation over here, 2 and 2 cancels out and we are left with 2x into 5, that is 10x. So 2 into 2x into 5 by 2. I hope all of you are understanding why I have written 2 into 2x here, because we got a 2x whole square over here. A squared plus 2 into a, this is the a term, that is 2x, and the b term which we just found out, that is 5 by 2. So the b term is here, 2ab. So we have to bring plus b squared plus, but actually 5 by 2 whole square was not there, so we have to subtract it also, that is minus 5 by 2 whole square, that equals 6. Again I am saying the 5 by 2 whole square term was not over here. We have forcibly brought it to maintain the equality in both the equations. We have to subtract the 5 by 2 whole square term. So now we are left with, looking at this first three terms, a square plus 2ab plus b square, that gives us a plus b whole square. The first three terms we have taken as a plus b whole square, minus 25 by 4, which is this term, that equals to 6. Implies that 2x plus 5 by 2 whole squared equals 6 plus 25 by 4, that equals 29 by 4. I have done this mentally. You can also do it in rough. I'm very sorry, I've done a mistake here. This should be 49 by 4. Okay, 4 into 6 is 24, 24 plus 25, that is 49. So it's 49 by 4. Now 2x plus 5 by 2 whole square gives us 49 by 4. So 2x plus 5 by 2 must be equal to plus minus square root of 49 by 4, that equals to plus minus 7 by 2. Now since I don't have space over here, I'll just erase the top portion. and continue the sum with 2x equals to, implies that 2x equals to plus minus 7 by 2 minus 5 by 2. We had plus 5 by 2 over here, so if we bring this plus 5 by 2 that side, so it's plus minus 7 by 2 minus 5 by 2. Either two x equals to plus 7 by 2 minus 5 by 2, that equals to 2 by 2, that is 1, implies that x equals to 1 by 2, or 2x equals to minus 7 by 2 minus 5 by 2, that equals minus 12 by 2, that equals minus 6. So 2x equals minus 6 implies x equals to minus 3. So again we have found both the values of x. Therefore x equals to half or minus 3. Thus we find the two values of x. With that we come to the end of this method, that is completing the square. Now we move on to the third method. So here we are with the third method of solving quadratic equations, that is solving by Sridharacharya's formula. Now Sridharacharya was actually a great Indian mathematician who devised this formula in the 11th century. Just imagine how many years ago. So this wonderful formula he derived to solve any quadratic equation. Actually the second method which we learned, that is solving by completing the square, that is actually the process which Sridharacharya applied. So the second method is also related to Sridharacharya, but here we get a direct formula to find the solution of any quadratic equation. Now before I give you any example, let me write the standard form of a quadratic equation once again. Ax square plus bx plus c equals to 0, where a, b, c are real numbers and a not equals to 0. Now if this is a quadratic equation, then according to Sridharacharya's formula, directly we can get the answer like this. X equals to, that is, we can directly find the roots of the equation like this. X equals to minus b plus minus root over b square minus 4ac, the whole expression divided by 2a. So x equals minus b plus minus root over of b square minus 4ac whole by 2a. This might seem a bit cumbrous, but there's no other way, you have to learn it. If you learn it, then you will see that you can directly get the roots of any quadratic equation. So now I'll show you two examples of using Sridharacharya's formula. We come to the first example, which is actually example 6, to demonstrate the Sridharacharya's formula. Now we have 2x squared plus x minus 4 equals to 0. Now to do this, to apply this rule, that is Sridharacharya's formula, what you have to do is first write the values of a, b and c. So comparing this with the standard form, we have a equals to 2, b equals to 1 as we can see, plus x, that is 1x, so b equals to 1, and c equals to minus 4. So we have x equals to, according to Sridharacharya's formula, minus b plus minus root over of b squared minus 4ac whole divided by 2a. That is, so now we just put the values of a, b and c. We have minus b, that is minus 1 because the value of b is 1, plus minus square root of b squared, that is 1 squared minus 4 into a into c, that is 4 into a, that is 2, into c, that is minus 4. This minus 4 must be written inside parenthesis, and we have 2a, that is 2 into 2. Now we just evaluate. Minus 1 plus minus root over of 1 square, that is 1, minus 4 into 2 into minus 4, that is plus 32, and we have 4 in the denominator. That gives us minus 1 plus minus root over of 33 by 4. Okay, now I erase this part. Either x equals minus 1 minus square root of 33 by 4, or x equals minus 1 plus square root of 33 by 4. You could have written this term at first and this term later on. It would be the same thing. So these are the two values of x. Now we see that 33 is not a perfect square. So the square root of 33 will not be a rational number. So we will just leave it in the surd form. That is, we will just write square root of 33 like that. So I'll just show another example of how to solve a quadratic equation using Sridharacharya's formula. Here we are with example 7. That is x squared plus 6x plus 6 equals to 0. Now again we compare it with the standard form of a quadratic equation, and we get a equals to 1, sorry for this, a equals to 1, b equals to 6, and c equals to 6 as well. Now we just straight away apply the formula x equals minus b plus minus root over of b squared minus 4ac whole by 2a. Now we just put the values. Minus b, that is minus 6, plus minus root over of b squared, that is 6 squared, minus 4 into a into c, that is 4 into a, that is 1, into c, that is 6, whole by 2a, that is 2 into 1. We keep on evaluating. Minus 6 plus minus root over of 36 minus 24 whole by 2, that equals to minus 6 plus minus root over of, now 36 minus 36 minus 24, that is 12 by 2. Now if you know surds properly, it would be minus 6 plus minus, so square root 12 is actually square root of 4 into 3. 12 is 4 into 3, so square root of 4 gives us 2, and we are left with root 3. So by 2, now we divide minus 6 by 2, that is minus 3, plus minus root 3. 2 by 2, that is 1, so we are left with only root 3 over here. Now I again erase the top part to write the solution finally. Now we have either x equals minus 3 plus root 3, or x equals minus 3 minus root 3. So we get both the values of x. Now with that example, I come to the end of this tutorial, where I discussed about what are quadratic equations and how to solve them. Now I have discussed here three processes of finding the roots of a quadratic equation or solving a quadratic equation. The first one was factorization method, second one was completing the square, and the third one here which I have shown is by Sridharacharya's formula. Now there is another method which I am not going to cover in this tutorial. It's not so easy to show that here on board, there is the graphical method of solving a quadratic equation. So I'm not going into that. So these are the main three methods which I have shown you. Let me tell you, this tutorial or this video is part 1 of quadratic equations. There's another video that is part 2 of quadratic equations, where I'll be discussing about the nature of roots. Now nature of roots, discriminant, all these things. So let that be reserved for the other video. With that, we come to the end of this tutorial. Again, let me remind you, if you have not subscribed to my channel, that is Easy Maths, do subscribe, do press the bell icon, and if you have really liked this video, hit the like button and share it a lot among your friends. Thank you so much.